This video will provide a brief overview of the different transmission methods that are commonly used for wireless microphone systems. Several factors should be taken into consideration to ensure the system you are buying will be the one best suited for your needs. These include, but are not limited to, transmission methods, multi-system limitations, form factor, batteries, encryption, antennas, and accessories. This video will focus on transmission methods and multi-system limitations, as well as RF environments. Form factors, batteries, encryption, antennas, and accessories are covered in another video. Wireless microphone systems are often classified as either analog or digital. This refers to the transmission method of the wireless system and not the audio signal itself. Analog systems transmit an analog RF signal that changes in voltage corresponding to the changes in frequency and amplitude. The wave has no single value, but is in a state of constant variation. Digital systems transmit an RF signal that has only two values, on or off. The way the transmission of those two values is timed allows the transmitter to communicate with the receiver in a language they both understand, similar to Morse code. Generally speaking, modern digital systems are superior to analog systems. While both systems utilize proven radio technology, offer audio quality performance and decent channel count, newer digital systems offer superior audio quality with the ability to use many more wireless systems in crowded RF environments. Transmission methods have a major impact on wireless systems and how well they perform in certain scenarios. Be sure to choose a wireless system that will work well in your application. Here's a brief overview of the most common wireless transmission methods. UHF, or ultra-high frequency, is the most commonly used transmission method for wireless systems. UHF is the designation for radio frequencies in the range between 300 MHz and 3 GHz. This is the same spectrum that TV signals, cell phones, and many other wireless systems operate in. Radio waves in the UHF band travel almost entirely by line-of-sight propagation and ground reflection. While it is true that UHF radio waves can penetrate some solid surfaces, it is always best to maintain constant line of sight between transmitters and receivers in order to prevent signal loss. VHF, or very high frequency, is the designation for radio frequencies in the range between 30 to 300 MHz. This spectrum is also commonly used by FM radio stations, two-way and emergency radios, as well as other long-range radio communications. Radio waves in VHF are much longer than those in UHF. As a result, their antennas need to be larger. Also, lower frequency signals do not penetrate solid surfaces as well as higher frequencies. Thus, line of sight becomes even more critical in VHF systems. 2.4 GHz systems are those that operate only within the 2.4 GHz band. 2.4 systems are typically digital and operate far away from TV and radio signals. They also benefit from universal regulations, meaning the rules for operating in 2.4 are the same no matter where you go in the world. This is a desirable feature for those who need to travel with their wireless systems. However, the 2.4 GHz band is also used by a multitude of consumer devices. These include phones, microwaves, Bluetooth devices, and most notably, Wi-Fi devices. Because 2.4 is a limited band used by a multitude of consumer and commercial-grade devices, frequency congestion can quickly become a problem. 2.4 GHz systems are typically not locked into a single frequency, but rather continuously scanned to find the best available signal. If the RF environment becomes overly saturated with 2.4 GHz devices, the reliability of 2.4 GHz wireless systems declines and RF dropout will quickly become an issue. Infrared or IR wireless systems transmit using an infrared light signal instead of radio signals. As a result, IR systems are not regulated by the FCC and do not suffer from RF interference and dropout. However, IR systems have a number of limitations that are unique to them. IR transmitters and receivers require constant line of sight, typically making them less reliable in situations where transmitters need to move around large open areas. IR signals are also not capable of penetrating any solid surface. This means their signal is limited to the room in which they reside and often can't be rack-mounted. And their receivers often cannot be rack-mounted. This same limitation, however, does mean that an IR signal is more private than traditional radio signals, which could possibly be picked up by other nearby receivers. IR systems are typically found in small classroom and boardroom applications with stationary transmitters and receivers. MultiSystem limitations refer to the maximum number of wireless channels that can operate simultaneously in any single environment. Exceeding these limitations will cause the collective wireless systems to interfere with themselves. Every wireless system is different, so it is best to determine the number of compatible systems you need to operate simultaneously before looking at other features. If you only require 2 or 3 systems in total, then most wireless systems will work well without any issues. If, however, you require 24 wireless systems to operate simultaneously, your options become much more limited, and special care and planning will need to take place. Pro tip: when purchasing any wireless system, it is also important to take into consideration your RF environment. This refers to the collective wireless signals that are operating in the area you plan to use your wireless system, whether they are under your control or not. For example, a house of worship may plan to add 2 wireless systems for their services. They currently use 2 other existing wireless microphone systems, bringing their total to 4 wireless systems. However, there are other wireless signals in and around the building that need to be taken into consideration. For instance, this building utilizes a number of dual-band Wi-Fi access points that operate in 2.4 and 5 GHz. This house of worship is also located in a heavily populated urban area with an event center located nearby that regularly operates a number of wireless systems on a much larger scale. Taking those factors into consideration, you can start to eliminate wireless systems that may not work as well in such an RF environment. Wireless systems that operate in 2.4 GHz, for example, would not be advised in this environment, since Wi-Fi access points could cause interference. This house of worship would probably want to explore a digital wireless UHF system, since it will offer a wide number of channels to select from, thus reducing the chance of interference from wireless signals produced by the surrounding venues. If you wish to learn more about wireless microphone systems, please visit our website for more instructional videos like this, or feel free to call or email us.